All right, so worksheet 9, this is what Mrs. Hoffbar and I refer to as the old stuff from this section. This is the Algebra 2 style questions. And I can already tell you right now that some of the techniques that I'm going to be asking you to use on solving these might contradict a little bit with what your Algebra 2 teacher may have taught you. What I'm trying to get you ready for is the next level of math. So rather than, sometimes Algebra 2 teachers like to teach it in a way where like everybody can get the right answer regardless of whether they know it or not. But in PreCalc, we got to remember, like, you guys are smart, smart, smart. So when I show you why we're doing this, then you guys can handle the real way of how we're going to solve it, okay? And I'll be honest, if you had me for Algebra 2, it's the same way I taught it in Algebra 2. So there's nothing new. It's not like Algebra 2 kids can't handle it. I kind of wish we all taught the same way. We don't. Anywho, digression. Let's move on. So on worksheet 9A, we have some, and I don't really think these two problems belong on this page. They're just kind of here to basically show you the difference between what we are going to be talking about and what kids confuse it with. This is actually a rational power equation. It's something we did back in chapter 2. So solving this, you need to isolate the variable. So your first step would be, of course, to divide by 15 on both sides. So right now you have x to the 2/3 power. Ugh, that's ugly. Equals 4. And then you think to yourself, okay, in math, I want to undo a 2/3 power, and how do I do that? Well, there's a few ways, but the easiest way is just to apply the reciprocal power. So instead of raising it to the 2/3, what if you raised it to the 3/2 power? Now, whatever you do to the left side of the equation, you have to also do to the right side of the equation, of course. Now, to make this a little more pre-calcy, do this without a calculator.
No.
Yes, you can.
Cube root of 16.
Nope, flip that around. This number here is the root. So this really says it's the square root of 4 raised to the 3rd power. So the square root of 4 is a dos. Raised to the 3rd power is 8. Very good. The answer is 8. So it's so weird. I'm not going to give you any more no calculator adventures in pre-calc for this semester. Yeah, we're done.
Wait,
yeah,
we're that first semester.
I said first semester, yes. Well, we have the unit circle stuff coming up in second semester.
Okay, so we talked about this the other day.
Oh gosh.
The seniors have already taken the SAT.
Right. Okay.
So
this next set of questions, these are truly what we refer to as exponential equations. So your variable is trapped in the exponent position. And this is where I am going to be a little bit different than some of your algebra teachers in how we train you to do this, okay? Oops, I didn't mean to do that. So we're going to be solving the exponentials first by isolating the exponential components. So right here, this 3 to the 2x power, I need to isolate that. So your first step would be to divide both sides by 50. So this becomes 3 to the 2x power. Is it? I don't know. 25? Okay, thank you. It feels like a Monday to me. Sorry. Okay, so here we investigate this question a little bit with some algebra eyes, and we say, like, okay, I have a base 3 and a base 25. They have nothing to do with each other. So I can't do any fancy algebra tricks. My x is trapped in the exponent, and I got to bring it down. And the only way to bring exponents down out of the exponent position is to apply a logarithm. So this is where I'm going to differ from some of your algebra teachers. I'm going to ask you to only use common log or natural log when I ask you to apply logarithms. There's many reasons why. The original reason is those are the 2 quick keys that you have on your calculator. The newer aged reason is this is how you're going to need to utilize this technique when you move on in your math curriculum, on to calculus and beyond. They want you to use common logs and natural logs all the time. Some of your Algebra 2 teachers taught you guys to use whatever logarithm base that matches the exponential base. So like, for instance, in this question, I know some of our teachers say apply log base 3 to both sides. Well, you don't have log base 3 button on your calculator. So then you'd have to go access the change of base, which isn't actually available to you all the time. So that technique doesn't work for my kids who are moving on in life in math, okay? So we're not going to do that. We're going to apply common log or natural log. So now here's the big decision. Which one do I apply? Common log or natural log? And the answer is it doesn't matter, okay? Either one. You just have to go with one. So I need someone to make a decision. That's the right answer, Taylor. And why is it the right answer? because,
She said
no. I personally always prefer natural logarithms.
why? 'Cause
It's 2 letters instead of 3, is less writing.
no, it's really because you have to like both of your kids equally.
It's also because my kids are named natural logarithm. But this has been something brewing since college for me. There was a differential equations class where I can't tell you how many logarithms I had to apply in my math. Hundreds. So real quick on, I was like, man, I'm just going to apply natural log all the time. And then I ended up writing like a doctor. So it just ended up being like a squirrely L. And my professor understood I meant natural logarithm by that. It was a pretty good gig for me. Okay, so when you're like, why does she keep picking natural log? Like, because I like it. I don't know. You don't like that reason?
No, I do not.
Well, I'm going to go with it anyways. All right, so I'm going to apply the natural log to both sides. Because in equations, if you apply something to the left side, a function to the left side, you have to apply the function to the right side as well. Why would I do that? Because nothing's going to cancel. You're like, why? Well, what it does do is we can use that property of logarithms that takes your exponent and pulls it down in front of your problem. So this 2x ends up being in front of the natural logarithm of 3. And over here on the right side, you still have the natural log of 25. Now notice I haven't actually reached for my calculator yet. I don't reach for my calculator until the very end of my problem because I don't want to do any truncation when it's not necessary. All right, y'all. Natural log 3, gross number. Natural log of 25, gross number. How do I solve for x? Well, I'm going to have to divide by 2 and the natural log of 3. So if you're lazy like me, you're just going to do that in one step. As long as you use parentheses, that's totally okay. Now I grab my calculator. Oops. It's not an eraser. Could you please grab your calculator? Everyone needs to type this. And if you're doing this in one step, just use your parentheses when they're appropriate, like right here. Make sure you're closing your logarithm functions when it's appropriate. So natural log of 25, close it, divided by natural log, divided by quantity, 2 times natural log 3. Sure did. And y'all should get the same answer. What did we get?
1.5.
Let's keep some more decimals here. 1.465. There we go. All right, so that's the idea. Let's skip ahead to part C. I need to isolate the exponential component to the question. So we're going to start by dividing by 150. Again, I should probably be able to do that in my head, but I can't. 600. That makes more sense. So now I'm at a point where I need to apply a logarithm. I want you either to use common log or natural log. Now this is the exception to that question. Here, everyone should be telling me the same answer.
Natural log.
Everybody should be using a natural log. Tell me why.
Inverses.
Very good. Look what beautiful thing's about to happen. When you apply the natural log to a base e, these cancel.
0.5.
Yep.
Natural.
So the 0.5x is just going to drop down. Now over on the right hand side, natural log of 600 is nothing pretty, so I'm just going to write down the natural log of 600, which is icky number on my calculator, and now I solve. Divide both sides by 0.5. Make sure you close your logarithm before you hit divide by 0.5. Usually typing is the most common mistake here. Is it 12.794? Thank you. That's what I got. What'd you type? Did you lose a 0? Natural log of 600 divided by 0.5. Now, someone who is like, no, I only use common logarithms. You totally could have done that. But your common log and your e wouldn't have canceled. So at some point in your math, you would have had to divide by the common log of e, which is nothing pretty, and you'd have to do it on a calculator. So it's not like there's a right and wrong way when you use common log and natural log, and I kind of tease you guys like saying natural log is always the right answer. There's an exception to that. Even I will use a common log when? If there's a base 10, yeah, if there's a 10 as a base, then even I will use a common log because I'm lazy. Above all else, lazy. All right, so that should feel kind of familiar from Algebra 2, and I know maybe the technique may have differed a little bit from your teacher, but the idea of applying a logarithm to bring an exponent down should be the same. So what about if we're trying to solve a logarithmic equation? Well, if your algebra is trapped inside of a logarithm like it is on number 3, part A, you need to undo the logarithm. So this is where, again, if you had me, we've already done this. If you didn't have me, some teachers don't teach it this way, so I'm going to give you a new word here, guys. We are going to exponentiate.
I remember that one.
I know.
I don't remember what it means. But I remember.
So in Algebra 2, I have kids write like little carrots next to exponentiate. And that maybe would trigger their memory, but I'm going to show you what it means in a second. Okay, so when you have an equation, you could do whatever you want to both sides of the equation, like within reason. Like you can add numbers, you can subtract numbers, you can multiply and divide numbers. You could square root both sides if you felt like it. And one of the other things you can do that no one ever thinks about until you learn about logarithms is you can create exponential equations by taking a base of your choice, shoving it under the problem, and hoisting the problem up into the exponent position. That process is called exponentiation. So, it is like a car jack, a tire jack, yeah. I've never thought of it that way. We should rename it. All right, so this particular logarithm, guys, what kind of logarithm are you looking at? What base is that logarithm? Yeah, it's a common logarithm, so it's a base 10. So, using a base of 10, I'm going to throw a 10 underneath both sides of the equation. And I'm going to kind of sneak them in there with little carrots, but what I'd like you guys to do, especially on just this first example, is rewrite what exactly you're looking at. So what you have right now is 10 raised to the power of log of 2, applied to a 2x plus 20. Yeah, we're getting there. And then over on the right-hand side, because I shoved that 10 underneath, what you have is 10 to the third power. So Daniel's telling me some simplification I can look at. Here's why we did that. 10 raised to the common log power. These are inverse functions, and they will cancel each other out. So the 2x plus 20 will drop down. 10 to the third power, better known as 1,000. This all of a sudden became a really babyish question. Subtract 20 and divide by 2. Nice job. Now, there is one more thing you got to worry about in logarithm equations. Extraneous solutions. You guys did a great job on your test yesterday. What can you not apply logarithms to? Negative values. So when I plug in a 490 into this logarithms algebra, am I going to get something negative out of it? No, it's going to be super positive and big. So I don't have to worry about extraneous solutions in that case, because when I plug in this x value, I don't get log of something negative. So I'm okay with keeping 490. All right, part B here. The logarithm, which is a natural logarithm this time, is not isolated yet. So the first thing you're going to need to do for me is isolate it by dividing both sides by 3. You could have raised the 3 up back into the power position. That would have worked, but it's really easier if you just get it out of there. So we have the natural log of x plus 2 equals 2. I'm sure you guys have noticed by now that I use cursive writing when writing the natural logarithm. So that way my bad handwriting looks a little fancier, number one, but also it doesn't look, I don't want some Algebra 2 student walking in and thinking I wrote I-N. Yeah, they do that. You wrote, oh gosh. And you fixed it because you knew I'd make fun of you, huh? Okay, what base is this logarithm? And if you forget, go check out your calculator because it's set up in inverses. Yes, a natural logarithm is a log base e. So when I exponentiate both sides of this equation, I'm using a base e. Now, that's gross. So you have e to the natural log of x plus 2 equals e to the power of 2. I have no idea what that is, but what I do know is that e and natural log will cancel. And then the only other step I need to do, this is the moment I grab my calculator. E to the second power, and then subtract that 2 over, and then you got your answer. And of course, it's going to be irrational, because e's are irrational.
5.
Yes? Thank you. So that should feel familiar to you from Algebra 2. Yes?
What are logarithms used for in day-to-day life?
Like applications of it? Yeah. Can we hold that conversation until tomorrow/Monday? Because we're going to have a gazillion applications of them.
Can you just give me an example of one thing that uses it? And I will ask no further questions.
Yes.
About that.
So a huge equation that we're going to be using is Newton's law of cooling.
Oh, okay.
Okay. Does that work for
I
you?
Understand.
Okay. Which, we got fun times coming our way on Monday. Newton's law of cooling. I love that we're teaching it right before Thanksgiving, because we could really make some cool questions regarding a turkey that comes out of the oven. Yeah. Which actually is like my dad's job. We should go all take a field trip to my dad's house.
Can we?
I wish you know what? He said yes, so maybe.
Please.
But not now. We don't have time.
No.
Ugh. Maybe only of us who are staying for second semester.
Yeah, I was staying anyway. My dad would kick my butt if I did.
That's true. I already made that phone call. Okay, let's take a look at number 4. If there's more than one logarithm in the question and they happen to be on the same side, or they're with something else, that is bad news. I can't exponentiate yet. I need to write this as a single logarithm. So you guys would have to use your skills from the previous lessons. What's the property of log plus log? How do we condense that back together? What do we do with the inside stuff here? We multiply it together. So in algebra, if you took 2x and multiplied it by x, you're looking at the log of 2x squared. Very good. Equals 3. Now this problem looks like it belongs in the section right above us. What base is this logarithm? It is a base 10, so you're going to use a 10 to exponentiate both sides.
So if it was log base 5, though,
you would use a 5, yep. So 10 to the log base 10, gone. These cancel. The 2x squared drops down, and you get 1,000. Before we square root, let's divide both sides by 2. So when I go to square root 500, you guys are good little trained algebra students, and your brain right away was like, plus or minus! Right? That's what you're saying. I got to put a plus or minus down because you've been marked wrong before on that. Now, this is the case where we're far enough into our math, we have to think whether we truly want the plus or minus or not. If you wrote down, and it's like 20...
No, we don't want them.
We don't want them.
Can't be a minus.
Very good. All right, so this is approximately 22.36, and the reason Daniel is saying no negative is because if you go back to the original problem and you try to plug in a negative 22.36 to either one of those original logarithms, logarithms are not defined for negative values, so it won't work. So this is where you just have to be a savvy math student and realize this is a case where I don't want a plus or minus. They show up in math, right? Sometimes you don't want them.
So, do you always want it to be irrational? Like that, or do you ever want us to write it as...
Oh, like 10 squares of 5?
Because I was about to write it as 2 root of 125.
Well, that wouldn't be reduced all the way.
It wouldn't? 125
No, because 125 has 25 in it. You gotta keep going. 125 is 25 times 5.
Oh, right, so it would be...
10 squares of 5. Right? 100 times 5.
I forgot about the fact that you can keep writing.
Yeah. So, to answer your question, it'll probably say round to the nearest whatever in the directions, and that's how you'll know. But of course, if it's rational, or irrational and reducible, I would accept either answer.
Okay.
Usually, we're kind of leading towards applications. So, like, if you think about application answers, like 10 squares of 5 is a weird answer to give somebody. 22.4, like, makes more sense to humans, you know.
Pushed into my brain.
I know.
To do it.
I know. You'll be flexible. You'll be fine. All right, so here we got to condense these logs together. There's a subtraction sign between them, so that means we're going to be using our quotient property. The other thing I noticed, though, is that there's a 2 in front of this logarithm. He needs to be stuck back up in his exponent. So this becomes x squared over 3. Very nice. Now this problem's extra easy because you have a 1-to-1 function, I shouldn't call it that, a 1-to-1 equation, where you have a log equals a log. So if you tried to exponentiate with an e on both sides, like boom, they're both going to cancel. So you don't even have to do any typing on your calculator. So x squared over 3 equals 12. Cross multiply both sides, so you get x squared equals 36. And then notice how Daniel just told me 6. Why did he not tell me negative 6? You can't apply a logarithm to a negative 6. Right there, you'd be undefined. Oh, your answer was because you forgot about it?
No, because I know that 6 is the square root.
I gotcha. All right, could you please find, we're going to skip those more practice problems. Could you look back at worksheet 8A? And thus begins our actual lesson.
I mean, what?
It's okay, it's a lot of that again. So that was review, right? Nothing there was really that new to you. I know. The logarithm chapter is one of my favorites in all the classes that I teach. And... Okay. Well, then you're going to love the thermodynamics stuff with the new
I love
cooling.
thermodynamics. I think it's super awesome.
Well, you're going to love our calculator work.
Physics-based,
yeah.
Like, if you can take any of these problems and put them in physics word problems, it'll make you far happier. You want to do them far.
Well, you're probably not going to be real happy because we don't get real deep into the actual physics components of it. We're the calculator of the human world. So, like, the scientists give us the information and then we, like, crank out the answers. Like, that's our job, you know.
Yeah, but
now.
If you make me think that I'm doing science.
Okay, I'll trick you. All right. Sounds good. Okay, so in this page, just like your notes sometimes have like one of the first problems are worked out. So as we work through this, you guys are just going to work with me and you're going to watch the board. The actual work is already on your paper, so you don't have to even look at your paper. In fact, I encourage you not to look at your paper because that would be cheating. All right, so number 1 here, example 1, I'm solving this equation, but this is a method that it's a bit of a shortcut. In Algebra 2, for my classes, we called this the baby base method. The official name is writing them in terms of their common bases. So when I look at this problem, I see an exponential equation, which I know I could apply logarithms to, but stop and look at those bases. You've got a 4 and a 16.
So 1 and a 4.
Isn't there a common base between a 4 and a 16?
4.
There's actually more than one answer here. 4 is a good answer.
2.
You could also write them both as 2s.
8.
Not 8.
No, you couldn't.
Well, unless you use rational things. Ugh, no. Okay, so let's stick with one of those. Do you want to use 4 or do you want to use 2?
4.
4 would be easier. So the news right here is this already is a 4, so I don't have to do anything on that side. Could you rewrite 16 so that it's a 4? Yeah, same thing as 4 squared, right? So now I got to think about exponent properties. Well, if you have a squared with an existing x power like this, you multiply them together and that becomes a 2x power. So you have 4 to the x minus 1 equals 4 to the 2x. So there's a school of thought that says like, oh, now you have to apply logarithms. Like, not really. Use your logic, guys. The only way for these two things to be the same would be if these two exponents are the same. So that's what we set up. X minus 1 has to be the same as 2x. And now we solve. So subtract the x over, and you got x equals negative 1. So that's a method for solving exponential equations if you notice that they have common bases. So what I want to look at next, we're going to skip that one for tomorrow, leave it for tomorrow. Don't look at your paper, it's already done on your paper. When I look at example A here, we have 3 to the x power equals 19. So in Algebra 2, you learn that baby base method, and everyone's like, I love that, it's so easy. So then they try to do that method on number 2A. It doesn't work. Are you going to be able to come up with a power that you can raise 3 to get a 19?
No.
Me neither. So we can't use that method. So what we have to do now is rely on our friend the logarithm, and we're going to apply either a common log or a natural log. So for this question, would you like to apply a common log or a natural log? Technically, there's no wrong answer. Common or natural, where do you want to go? All right, girl, Taylor. All right, now what's fun is on your paper, they used common log, but you're going to notice we get the same answer. So if we apply a natural log to both sides of the equation, while nothing does cancel, the x does come down in front of the logarithm. So this becomes x times the natural log of 3, which is just some icky number, and then it equals the natural log of 19. So if I'm trying to algebraically solve for x, I would divide both sides by the natural log of 3. Could someone type that in for me? Because this is not the same math that their work shows, but when we type in the natural log of 19, close it, divide by the natural log of 3,
2.68.
which is what they got. So they used the common log, and the answer is it didn't matter which one you did, because the ratio of the logarithms is how it works out. All right, part B, again, it's already done for you on your paper, so just watch with me. I can't use the logarithm yet because the exponential is not isolated, so we're going to add the 6 over. Equals 7. Now let's apply a logarithm. Everybody and their brother should choose the same logarithm this time, though. Unless you're weird. All right, natural log. That would be smart because the natural log and base e will cancel.
What if you put a regular?
It would still work, but what you'd have to do is you'd have, that's a great question. Okay, so you'd have log of e, which doesn't cancel to a 1. So you'd have to divide by the log of e as well as subtract 1 and divide by 8. So here's what happens sometimes with kids. They forget that natural log and e cancel out. And if you think about your calculators, guys, I don't want to pull mine up because it takes forever to pull up, but you see right above the division key you have an e? That's the number e, like with no power associated with it. Could you just type the natural log of e and tell me what your calculator spits out? It's a 1. So when you apply the natural log to an e, you get 1. So the kid who doesn't realize these cancel, they end up dividing by the natural log of e, so they divide by a 1. Does that do anything to your answer? No. So the kid who knows they cancel is taking a shortcut. The kid who doesn't know they cancel is just dividing by a 1 like a silly pants. Okay. So right now, I don't really care to type in my calculator yet, because I see I have a couple more arithmetic steps, right? I got to subtract the 1, and then I got to divide whatever this number is by 8. So technically speaking, you could type that baby in your calculator now. You could hit enter in between. You just want to make sure you don't truncate your decimals as you go. So you're either using your answer key or whatever. So according to your textbook, we get about 0.12.
I made a mistake.
Uh-oh. Could be a me thing. This isn't 0.7. It looks like 0.7. Natural log of 7 minus 1. Is it not 0.7?
No, because I didn't put them in
Parentheses?
the whole natural log in parentheses.
Okay, the only thing that's in the natural log is 7. So it's the natural log of 7, subtract 1. You either need to hit enter, or you need to use parentheses before you divide by 8. I mean, maybe the book key is wrong. I don't know. Did anyone get 0.12?
Okay, there we go.
Okay.
Got it.
Okay. Now, are you typing it in one step, Taylor? So you have to put parentheses like this.
Also, don't use the negative key instead.
Yeah, subtraction, not negative key, that too.
I made that mistake.
Oh, man.
First, I didn't put them in parentheses.
Oh,
and then I used
this is not your problem,
key.
Daniel.
I hate calculus.
Were you able to get it, Taylor?
Hey, that's a joke. That's why I said.
You're very difficult to deal with today.
I'm in a weird mood today.
Okay. All right, so let's take a look at number 1. Finally, you guys can work through some problems with me. Number 1, y'all love the baby base method, whether you recognize it or not. Do you recognize in number 1 that we have common bases between a 9 and a 3?
Yes.
What is the common base?
3.
So could you please rewrite 9 so that it's a 3?
3.
Yeah, I got you. So this is 3 squared. And then because there already was an existing x on the power here, this becomes 3 to the 2x power, because you multiply those together, right? Equals 3 to the 3x minus 4 power. The only way that these would equal each other is if your powers were matching. So 2x has to be the same as 3x minus 4. I think you get x equals 4. However you solve that, you get x equals 4. Cool. I think you have a common base on number 2 as well. Do you see it? There's more than one answer.
No, I really.
On 1?
No, on 2.
Oh, on 2?
I don't know how to.
Anybody ever thought about a common base there?
Because we don't want them to be irrational, right?
Well, irrational means you can't write it as a fraction. Fractions are fine. What do you think, Brandon? So you're going to change them to 1/2 bases? I think what you want to think about is this. Is that the same thing as 1/4? Okay. So let's keep on track with that. If I could rewrite both these bases as 1/2, that'd be great. So 1/8 is 1/2 to the what power? What were you going to do? You were going to square them? That changes your exponent. Were you going to apply it here? You have to be careful because this isn't really a 1/4. It's a 1/4 to this power. So you can't just... Here, let me show you something. I think I get what you're saying, but this will be easier. If you downgrade the base to a 1/2, well, upgrade technically to a 1/2, and you involve the existing exponent right now, this becomes a 1/2 to what power? And this is where the distribution could come in right here. 4x minus 2, very good. So this becomes 1/2 to the 4x minus 2. And then this becomes a 1/2. Yes, good distribution. 33 minus 3x. There you go. last class, they went with 2 as their common base. They changed everything to a 2. Now, what did they have to involve in their exponent? Not fractions. How would you flip it?
What?
How would you make a fraction base flip to a not fraction base anymore? They had to use a negative. So they called this 2 to the negative 2 power, and they called this 2 to the negative 3 power. We decided pretty quickly that that probably wasn't the most efficient way to change your base. But either way, the answer is going to come out the same. Like, there's a lot of things you could do, and that's, I think, where Brandon was heading with his. It's easiest. Does this equal 35? So x equals 5. It's easiest if you guys look at your bases in terms of like, okay, who is typically the smallest one that they have in common is the easiest way for brains to figure it out, okay? We're going to be continuing on with this, but what you guys need to think about for your homework, and I don't know how many of you have, you're about halfway through your homework check as of now. The new homework check, okay?
How?
So the first assignment was that TVM solver from your calculator business. I don't think anyone's looked at that yet. You need to start looking at that. Okay? Your official assignment for tonight is worksheet 11. All of the circled questions from worksheet 11, 11B. And then technically you can start the next book assignment, page 196. Not do all of them, because some of them are nasty, but you have to kind of pick and choose which ones are good Algebra 2 style review questions, things that you can do from Algebra 2. We're going to work more on this lesson tomorrow, and then you're officially going to be assigned the rest of the bookwork there. Okay?